Let me write that down. So we start with statistics. And we can either have what is called descriptive statistics, or the other way that statistics is done, you can have inferential statistics. And they're both not terribly different from each other. Descriptive statistics simply allows us to look at a certain set of data that we have and make some comments about these data. And I'll give you an example for that in today's lecture. Inferential statistics is basically making some educated guess from a small sample about a big population. And we are going to do both in the next few weeks. I will introduce you to the concept of descriptive statistics. And then once we've done that more or less, we will discuss inferential statistics. And it allows us, with these tools, it allows us, for example, to summarize data, but also it allows us to compare data with each other. And just to give you an example for that, so we can compare data with statistics. So let's, for example, say I do an experiment. For example, I have 3 plates, agar plates, and I spread E. coli onto these agar plates. And then I count how many cells are growing on each of these agar plates. Say I've got 120, 112, and 108 colonies growing on these plates. Not terribly exciting. But now I test an antibiotic and I prepare 3 other plates that contain this antibiotic. I spread my cells, and I find, and again, count the cells, and I find that I have 98, 105, and say 110 colonies growing on these plates with antibiotics. You can imagine the experiment? Pretty simple and straightforward. But now my question is, does this antibiotic actually work? If the antibiotic works, then I would expect less cells here compared to the cells here. Does it work, the antibiotic? Yes or yes? Yes? Maybe. Actually, I haven't done the test for that, but there are tests that we can do just simply from the data that we have to see whether the antibiotic was effective. And by the end of this statistics sessions that we are doing, you will be able to tell me, yes, the antibiotic works, or no, it doesn't. We can also look at marks from students. And one of the questions that I'm quite interested in is, are men or women more intelligent? Who? Who? I better not say anything, but we can look at that in our statistics session and say, right, let's see who performs better under certain conditions. Yeah? Sorry? What task they are, yes. I can tell that men are probably performing worse when it comes to knitting or breastfeeding. Yeah? Although I don't want to generalize here. So, today I just simply want to entertain you and give you the impression that statistics isn't that bad, but also we want to do a little bit of this topic here of descriptive statistics. And for descriptive statistics, we want, first of all, we want to discuss the concept of central tendency. And you have to get used to the fact that for statisticians, the more complicated the phrase is, the better it is, because there is an indirect correlation. Again, we are talking about that. Indirect correlation between the more complicated the word, the easier the term. So, in order to demonstrate the concept of central tendency, I need some volunteers. What we are doing here, while they are getting on, we have 180, 190, that's all in centimeters. What are you? 190, oh cool. Huh? 180. 82. Okay. No. Go on, behave yourself, young lady.
Oh, a phone!
Can you give that in centimeters? Huh?
Yeah, I like that number.
164. Good. Next. Hundred and come on. One 167, okay? Next. Quick. Two more. No, you're not.
This is weird. Where is the big
159.
That's weird. Where does it say 100 then?
I thought a metre was about 80.
Okay, come on.
That's not fair. How do you get it reach?
Yeah, it's always a thing for the vertically challenged.
Somebody
Shall I help you? 165. Yeah, 165. And last one, Louise. Let's see.
Oh my god, I see now why I bought something. Wait, which one's included? 178. 178.
178. Oh, okay. 178. Fantastic. So. No? I need you still. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. Yeah? So 9 data points. And of course, we could now calculate the average of these data. Can somebody please do the honors of the calculate? You all know how to calculate the average. Yeah? So you take 180 plus 190 plus 190 plus 182, and all this, and you calculate the average of that. 175 centimeters. So, for this average that we have taken here, I just taken a sample of all students, these 9 very fine characters here, and the average, the arithmetic mean of this, and it's usually abbreviated with an X with a little line over it, X bar, is 175 centimeters. Yeah? And you can do all this average. It's very easy to do. Now, you noticed how long it took me, well, how long it took them to measure each other. And it can be quite time-consuming. So can I come up with another way of finding out the average height of somebody? Sorry? A questionnaire, yes. But, you know, I don't want to do a questionnaire. Sorry? Oh, Debbie has a great idea. I line you up according to height. This is not a yo-yo. I line you up according to height. So, tallest over here. Does that look about right? Yeah?
Go for it.
That looks pretty good. And now, what I can do now is, I can find out the person in the middle. Right? Now, yeah, I know it's bright. You know what I'm suffering all the time. Now, this thing, what I'm doing now, is called the median. Yeah? So, I pick out the person in the middle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So, you are in the middle. Yeah? And I know your height because you were first. So I can say the median of that is 180 centimeters.
5 centimeters.
Yeah? 180 centimeters. I just have to measure one of them. That's very easy. Here's another question. Here is a very tricky question. It was easy to pick out the middleman. Yeah? But what would happen, because it is an odd number here. That's quite an odd bunch. But what would happen if we had an even number? I pick out the two middle ones. If you go away for a moment, but come back then. So I have 2, 4, 6, 8. Where would be my middle? It would be exactly between the two of you. So how would I deal with that? Add them together and divide by 2. Exactly. Yeah? So if we've got an even number, add them together, divide by 2. Yeah? Fantastic. You can go back to your group. So this is the median. We can also pick out another one. We can pick out the mode. The mode is the number of heights that occur most often. That would be 190. So that would be the mode. Mode 190 centimeters. Yeah? Are you happy with that? It's not a big problem then.
Can we pick them up?
Shall we let them go back? Yeah? But before you go back, big thank you. Well done. Sorry?
That was worse than Butlins and I didn't know what mine was. I've got spots in front of my eyes. That's really bad.
And I told you, hands off the chin at lunch. Yeah? You get used to it. So, we have, in principle, 3 measures of central tendency. Central tendency. We have the mean. Usually it's the arithmetic mean. There are other types of means, but they are not used that often. We have the mean. We have the median. And we have the mode. The mode usually is the least used of this group. So we don't really need to worry about it. Although it's probably important to mention that if you have a data set, so for example, 1, 2, 3, 4, 5, let this be a data set. We can calculate the mean. 3, 6, 10, 15 divided by 1, 2, 3, 4, 5. So the mean in this case would be 3. The median in this case would be 3. The mode would be, it doesn't have a mode. Yeah, there's no mode there. Also, a set of data can have 2 modes. Yeah? In this case here, obviously these numbers would now be different. But here you would have mode. What would be the mode of that? 1 and 3, exactly.
But they don't tend to like that though, do they? When there's 2 or 4 modes.
Sorry, they don't like that.
I think they tend to like that when there's more than one mode.
Well, Tiffany made the point that they don't like it. Well, you like it or not, it's 2 modes. And we very often say that this here is a bimodal.
Can you have more than two?
Yeah. You can have more than two, although then people say it's just, it's rubbish. Yeah. And usually it's bimodal, and then anything higher, we don't really deal with that. It's quite interesting because when I look at, for example, exam results, we are talking about that later on in these sessions. We can have a function. So here are, for example, the marks. And here are the number of students. And if it is a test or an exam that requires maths, it usually shows something like that. This would be a monomodal function. It has one peak. Sorry, that's not maths. That's not maths. That is an essay. That is an essay where people have to write an essay. An essay. Yeah? Most people deliver something that is halfway decent. However, if it is maths, what you find is the following. Something like that. This is a bimodal distribution because it has two peaks. Yeah? Bimodal. These guys here just simply don't get it. These guys here got it completely and they don't make any mistakes, really. So I call the bimodal sometimes the camel distribution, and the monomodal, that's for me the brontosaurus distribution, because it has the biggest hump in the middle. So these are the measures of central tendency. Can you think when one of these central tendencies is better than the other to use? I showed you we have certain measurements. We had 180, 190, 190, 169, 172, 5'4". Oops. Yeah, 54. It's a bit weird. So you could calculate, or 5'4", let's put it like that, 5'4". Yeah? Could you, 1, 2, 3, 4, 5, 6, let's have another one, 165. Can somebody please be so good and calculate the average of these data, including the 5.4? $153? Yeah? What do you get? So the mean of that would be 153 point something. Yeah? 153, that's the mean. That's the mathematical average of that. Now I can look at these data and say this 153 is smaller than this, and this. It is smaller than all but one of the data. It's somehow, you have an uneasy feeling about this mean. Does it look right to you? No. Why doesn't it feel right? Because you have a data point in there that is sort of completely the odd one out. It's an outlier. It's an outlier. Okay, can you do the median of that? So let's order them. 190, 190, 180, 172, 169, 165, 5.4. I've done it in descending order. 1, 2, 3, 4, 5, 6, 7. So what is the median? 172 here. Yeah, that is the median. And the way you can do that really very easily is, okay, 1, 1, next, 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 so that's the one that's left. So here our median is 172. Does that look better? Yeah? That looks much better, 172, because the simple explanation is the median is not sensitive to any weird data. So the median, whenever you have an outlier somewhere, it will F up your mean, but it will be okay with the median. The mode in this case doesn't help you because there is no mode. There is no number that is most frequent here. So, 190, yes, sorry, yes, you're absolutely right. Sorry. 191, there's no mode. Yeah? Then the average changes, yes. But only marginally. Okay, you got it? Mean, mode, and median. Let's just simply forget the mode. We don't need that. So we deal with mean and median. Median is good if you have any what is called outliers. Okay? So this is measure of central tendency. Well, so far it's not too bad, statistics, is it? Now, what we can do is we can also look at how widespread our data are. And this is called, actually, the measure of the measures of dispersion. It looks how much our data are spread out. And one way of dealing with that is we can define what is called the range of our data. And the range of data simply is the largest minus the smallest data point. Yeah? So I think going back to the previous example where we measured people, our largest was 190, and the smallest is 159. So our range of data, the range would be 31. So that would be the range. And it just simply tells me how much the data are spread out. If the data are hugely spread out, then it means I have very tall people and diddy people. Yeah? So the data would be hugely spread out. If I have everybody the same size, the data would not be spread out at all. It would be absolutely precise, 178 centimeters, for example. Yeah? Which measurement is more accurate? It is when the data spread is pretty small. Yeah? Because then I don't have to worry about, tall or small people. And if I do an experiment in the lab, and I told you about, for example, the bacterial cultures, and I've got something like 100, 574, and 92, there's a huge variation in the data. Whereas, for example, with my antibiotics, I have 50, 51, and 49. So I can do the average, I can do the mean. Here would be 50. Here I have a huge variation. So which experiment should I repeat? I should repeat really the first one because, maybe there's something weird going on. Sorry, say again?
If it come out the same, would you just take the 100 from the 574?
Yeah.
That's it.
And I'd probably say why there's huge variation.
Yeah. So, the larger the variation, the more problematic in a way is the experiment. Do you think there is a difference between them? Would you say there's a difference between with antibiotics or without antibiotics? Yeah? We will find out at one point. Yeah? Now, we also have different ways of dealing with these measures of dispersion. How we can measure that in the best possible way. And how can we visualize this in the best possible way? And I'll tell you that on Thursday.
Oh,